Hello, and welcome to this Xilinx Quick Take video that will introduce you to Tandem Configuration solutions. Tandem Configuration is a technology that has been designed to improve FPGA configuration times when using Xilinx PCI Express IP. In this video, we will show why this technology has been developed and the specific goals and capabilities for each variant of the solution. We will talk about what is unique about the Tandem IP, walk through IP generation, and show some results based on a reference design. As FPGA sizes have grown over the years, it has become increasingly difficult to meet the configuration time requirements for PCI Express. Xilinx has developed a two-stage configuration solution to meet these needs. The name Tandem comes from the fact that two bitstream stages are loaded, one after the other. Think of a tandem bicycle. Tandem configuration is supported for specific 7 series devices in Vivado. There are two tandem configuration solutions, Tandem PROM and Tandem PCle. These two variations differ primarily in the way the second phase of configuration is done. Tandem PROM stores both stages of the FPGA image in a single bitstream stored locally. Configuration time is reduced by first configuring only those portions of the FPGA that are critical to the operation of PCI Express, including the PCI Express block, serial transceivers, and clocking resources. These resources are configured via an onboard PROM device, such as an SPI or BPI flash, just like a standard configuration. Once these key pieces have been configured, the FPGA is allowed to begin operation, and the PCI Express hard block is able to accept and respond to configuration traffic over the PCI Express link. It will also handle reads and writes sent across the PCIe link so that systems will not hang. While the system is enumerating by configuring the PCI Express core registers, the remainder of the FPGA is configured via the same PROM device. Once the second stage completes, the device enters full operating mode. In essence, the bitstream is rearranged so that the critical PCIe portions are configured first, then the FPGA implements a partial startup sequence, and then the remainder of the FPGA is configured, all through the same flash device and configuration interface. Tandem PCIe builds upon the Tandem PROM concept, but rather than programming the second portion of the bitstream from the PROM, it is delivered to the FPGA via the established PCIe link. The structure is the same as for Tandem PROM, with the critical PCIe logic delivered in the first stage from the boot flash, but in this variant, the internal configuration access port, or ICAP, is also included. After PCIe enumeration has completed, the system delivers the second stage bitstream over this PCIe link to the ICAP, configuring the remainder of the device. The same handshake mechanism is used to complete the overall configuration, bringing the full design into user mode. Note that the Tandem PCIe variant has the additional benefit of reducing the size of the boot PROM, as only the first stage bitstream must be stored locally. It is important to understand that each configuration bit is programmed exactly once, and that the second stage bitstream is tightly coupled to the first stage. If a new design version is created, both bitstream stages must be updated. This is not partial reconfiguration, but the same underlying silicon technology enables both solutions. To enable tandem configuration, the user simply checks a selection in the Core Gen customization GUI when creating the Xilinx PCIe IP. For each supported device, any package or PCIe location may be selected. There is no restriction on the customization of the IP either. In this example, we will select Gen 2 by 8 for a Kintex-7 325T device, but Gen 3 is supported for Vertex 7 devices that can handle that lane rate. By checking either of these boxes, the PCI Express core will be floor planned and additional user constraints are created. These directives tell the place and route and bitstream generation tools that certain pieces of the design are to be configured first. The IP also contains boundary logic that allows it to function within a partially configured device. The user integrates this PCI Express core along with the provided user constraints into their own design and runs the implementation tools normally. An example design is generated along with the IP core and is a great starting point for the design integration. A few details must be supplied by the user, such as the reset pin location. Custom scripts are automatically called to define the two configuration stages, and the design segmentation itself is controlled by the place and route algorithms. The reference design shown here applies Tandem PROM to our Kintex-7 Connectivity targeted reference design. You can see the main PCIe core region here. P blocks have also been created for the global clocks, and clock management resources, the reset pin, and the configuration components. All of these highlighted frames, plus the necessary routing between these regions, will be included in the first stage bitstream. Because this solution is built with standard FPGA resources, there is some variation in the first stage bitstream size. It will depend on the IP option selected and how the design has been placed and routed. The bitstream generation log file reports the final size of the first stage design. The designer then takes this number to calculate PROM bandwidth required to meet their system requirements. You can see that the first stage bitstream size here is approximately 17 megabits. This particular example is for the Kintex device that is on the Xilinx KC705 demonstration board. A full bitstream for this device is about 87 megabits, so Tandem reduces configuration time by more than 80%. Using a by16 BPI flash running at 50 MHz, it will take less than 22 milliseconds to configure. This is, of course, well under the 100 milliseconds expected for PCI Express, even when considering power on reset time. Bitstream compression is used to further reduce the bitstream size and configuration time. The effectiveness will vary from design to design. For this TRD example, with compression enabled, the first stage bitstream reduces to 13 megabits, shrinking configuration time down to under 17 milliseconds. To summarize, we have shown how Tandem configuration can be used to reduce configuration time and PROM sizes for 7 series devices when working with Xilinx PCIe IP. For more information, please consult the latest versions of the 7 series PCI Express product guides. This concludes the Vivado Quick Take on Tandem configuration. Thank you for watching.